Okay, so we're going to talk about accuracy and precision now. I'm at school doing this video, so hopefully we shouldn't have any dogs interrupting us. So let's go. So we know in science we often make measurements, and whenever we have people making measurements, there's going to be some error involved, right? So that's what accuracy and precision have to do with, okay? So we're going to discuss these two terms. So precision and accuracy, they're both going to describe how reliable a measurement or a set of measurements are. So accuracy is going to tell us how closely a set of measurements is to the theoretical or the accepted or known value of a given quantity. So let's look at this in terms of a target. So we all know what a target is, and obviously the accepted value of a target would be the bullseye. That's all what we're aiming for. So when you're going for a target, you want to hit the bullseye. So this would be an example of accuracy. An accurate shot with an arrow would be somewhere close to the bullseye. Okay, precision is going to tell us how closely a collection of measurements of a single thing are to each other. So in other words, if a set of measurements of a single thing has high precisions, those measurements are close to the same value. So let's look at our target again. So here's an example of precision. So our accepted value is still the bullseye. So these aren't accurate at all, but see how the arrows are all really close together? So this is very precise. Every single time this person shoots, they hit the target in just about the same spot. So they're very precise. They're not very accurate because they're not hitting the bullseye, but they are precise. Okay, so let's look at this target. So this person shoots amazing, right? They hit the bullseye every single time. Their arrows are pretty much right on top of each other. So these arrows are accurate and precise. Okay, so look at this person. This person, every time they shoot, their arrows go every which way. So this is an example of arrows not being accurate or precise. Neither accurate nor precise. Okay, so we can actually quantify that accuracy or precision by calculating percent error. So we can see the formula for percent error right here. So percent error equals the absolute value of the actual minus the theoretical divided by the actual times 100. So let's look and see what that actually means. So the actual actually means what you know the answer to be. Okay, so when we were talking about that bullseye, the target, the bullseye was the actual. Okay. And the theoretical is what you have calculated the answer to be. So that's your guess, that's your hypothesis, that's what you have calculated in your experiment. Okay, we're going to go ahead and do a practice problem now. And in this practice problem it says, it is known from the periodic table that carbon has a mass of 12.01. So that actually is our actual value because that's what is known. Okay. Then it says, if you weigh carbon 10 times and you get an average of 11.99, what is your percent error? So remember the equation we just learned, and you have it on your paper. I can't really show it to you right now. But, so percent error equals absolute value, the actual, which we just saw is this right here, 12.01 minus what we just calculated in the lab, so that's this one, so 11.99. Okay. Divided by the actual, 12.01. Okay, so we gotta do that math. Okay, so on my calculator, I'm taking 12.01 minus 11.99. And I don't get a negative here. If I did, I would simply make it positive because of those absolute values. So I get 0.02. Then I'm going to divide that by 12.01. And then I'm going to take that and I'm going to multiply by 100. Okay. So my answer is 0.17%. Okay. Okay, we're gonna go ahead tomorrow in class, or Friday and Monday, depending on what group you're in. We're gonna do a lab with this in class, and so we'll practice some more with it. So mainly, you need to know the difference between precision and accuracy, and then you'll be able to calculate percent error throughout the whole semester. Okay? Make sure you write down one question that you need to know, or that you don't understand, or one question that you would like to know more about. Thank you. Bye.